here. You got to have at least one permit statement at the bottom. The example, the individual abusing their internet privileges. Hey, we'll go in and we'll deny, I spelled deny wrong, deny host 10.16.12.7. Apply it. The access control list is a two-step process. First we write it, we write the list, and then we apply it to an interface. Apply to an interface. And yeah, apply spelled wrong. Apply it to an interface. So, applied it to the interface. And you know what? Whole internet went down. Everybody lost connectivity because forgot the permit, P-E-R-M-I-T, any, and permit any is the command that we use to permit everything else. So once I did the deny, I had to do a permit any because of this implicit deny that's at the end of the access control list. We should always put the more specific commands at the top, the generalized commands, and that's we want to deny this one individual IP address before we permit everything else. If we permitted everything before we did the deny, then the one that we did deny under permit would be permitted also, because they would just go in, see the first thing in the list, permitted, and off they go, because you apply the first thing that affects the system, and then you move on from there. This is the pretty part of it. We have a packet come in, an access control list at the router interface. This is, first we write it, and then we apply it. And this is what the access list, access control list, and the access groups are all about, and we'll do those things. And then it comes into statement one match. If it's a yes, if it's a permit, it does that. Doesn't go any further. Doesn't look at statement 2 or statement 3 or statement N or statement anything else. When we go down this, statement 1, no. Statement 2, no. Statement 3, no. If nothing applies, we get down to statement, I'm out of statements. So now the implicit deny takes over, and it's going to drop the packet when we do those things. So we need at least one permit statement. Mechanism used to control flow of network traffic, identify the traffic to permit or deny it. Define a group of traffic and apply a condition based on a criteria, and applied by using the Cisco iOS statements on a device interface, either inbound or outbound. We have to define the rules as either inbound and outbound, and we'll do that in the demo for these things, and validate each packet whether to block or allow, permit or deny them. The types of lists that we did, we have a standard which is based on the source IP address, and it should be applied as close to the destination as possible. Talk about that here in a second, why we wouldn't want to do it closer than that. And then we have the extended, which can use a source and destination IP address as well as a TCP port number to permit resources or to permit services or to deny services for these things. Standard or extended can be numbered or named. The numbered list 1 to 99, and I was right first time 1300 to 1999. Originally we only had the 1 to 99 and 100 to 199, and then all the other protocols went away. When all the other protocols went away, all of a sudden a whole bunch of numbers are available. So let's just use the numbers so that you can have what there's 700 access control lists. That's a lot of access control lists. And that's just for the standards, and you can have the same number over here, 700 for the extended list. So if you need a bunch of them, you can have a bunch of them. 2,000 to 2699, 1,300 to 1999 for the numbers, as well as the 1 to 99 and the 100 to 199. Named access control lists provide editing features for inserting and deleting command lines. And again, we can use the numbered or the named. And since one's not really that, actually the named, which are easier to edit, are probably easier to write too. You can make your own decision as we do these things. So the format here, access list to permit, access list to deny. We have to write access list and the number for each of the statements that we're going to do. A standard numbered access control list filters the IPv4 packets by matching the source IP address, and that's the only thing it's going to use. Each access control list comprises one entity, many lines of the configuration, the access control entries for the access control list, is enabled in one particular direction on an interface. We can use the same access control list multiple times if we want to, but if you think about it, probably wouldn't mean a whole lot to go on the multiple interfaces. The extended list, the IP access list, and then the number permit host 10.253.1.80 port 80, and then deny equal to FTP. This is a simplified version of what the extended list would be, because we have to specify the protocol. If we're going to do ports, we have to specify the extended, the source and destination IP address for these things, and we will look at one of those. Filters many parameters, the IP address, port numbers, and protocols are going to be used for this thing. More usable than the standard, and they should be applied closest to the source. It may be applied in any direction on the interface, in any direction inbound and outbound. The direction on the interface is going onto the wire or coming off of the wire. And that's the easiest way that I can do it. The kind of the summary, and then we'll do the demo, and then you can get to work here. More specific rules at the top, applied from the top down. Have to have at least one permit statement. There's an implicit deny at the end of the access control lists. Once they're written, they've got to be applied as either inbound or outbound on the interface. And one that I didn't say, and it's really not pertinent anymore, I don't think, but it's one of the rules. We can have one per protocol, per interface, per direction. And the protocol, we're really only using the one protocol anymore, which is IP. So let me see if I can find an access control list to go here real quickly, and then you can get to work on it. Let's see, this says it was done in 2019. I had a couple of them, and this one works as good as any. As soon as he starts up, you can see spanning tree here going. I've got a web server running over here. We could, actually let me try one of these others, because it's going to be easy to explain the why, the destination, and the source for it. ACL demo not done. I don't know. I'll probably wind up with the same one now that we have, now that we have this. This is the one that I kind of really wanted here to do these things with, or to do this thing with. The first thing that we're going to do is, it says the access list, whatever we can play with it, we'll make it up as we go. We have a web server running over here, 192.168.2.2. 168.2.2. I'm just going to do something relatively simple here to demonstrate the named, the numbered, the named, the extended, and the standard list. So let's say that here we want to allow 1.2 to get to the web server, and we don't want to allow anything else, or maybe we want to allow this network over here, which is the 3 network, to get there. So to do that, I would write the access list, and let's see, enable, and I'm going to do a standard list first. Config T access list 1, because that's going to put me in the standard list, and I'm going to permit host 192.168.1.2, And that's all that we can do on a on one of these. If I do a question mark, the only thing I can do is a carriage return. Let's say that I want to do access list 1, permit, MIT, and we're going to permit this other subnet over here. What we're going to wind up doing is denying the 1.3, and I'm going around the world to do that. But this is the 3 network, so we're going to permit the 192.168.3.0. Let's do 3. Let's try 3.0. 0.0.0.255. We're back to wildcard masks again to be able to do these things. So we're going to permit that whole address and the single IP address from the 1.2, which winds up meaning that 1.3 gets stopped. On this one, it's kind of obvious that if I apply it inbound here, it's not going to work on everything. If I apply it here, then I've got an issue. If that it's not going to do everything, so it's got to be outbound. If I had only done the one address, the 1.2, and I talked about this one, if I stopped it here, if I applied it inbound here, then there may be resources over here that I couldn't get to. So the standard lists are going to be closest to the destination. And those of you weather guys, weather-wise people, San Diego has great weather. So SD, standard, closest to the destination. I told you I got all sorts of stupid ways to remember things, and that is one of those. So if the standard is closest to the destination, the extended is going to be closest to the source. So now that I've written this list, and I got to see the interface here, which is going to be gig 00. So now I need to apply it. So I'll do interface gig 0/0, and then we'll do IP access group 1, and then it's going to be outbound, because as it comes out of the interface is where it's going to be applied. So inbound and outbound. And my way of thinking about it is going off of the wire is inbound, going onto the wire is outbound when we do these things. And they talk about the man in the router, and the inbound and outbound is referenced to the man in the router, and I got that messed up for a lot of years. I had to mount a little man in the router and say, oh, if it's going into the interface from the router, it's inbound. If it's going to the router from the wire, it's inbound. Otherwise, going out onto the wire, it is outbound. So now then, let's see if any of our stuff works. And we permitted 1.2, I think. Since we didn't get protocol specific, we're going to permit everything here. So let's see if we can ping 192.168.2.2 to do this thing, and not looking good, huh? Okay, there we go. And can we get to the web on it? And can we get to HTTP 192.168.2.2? And we can get there. Let's see if we can get there from the 1.3. And we hope not, right? Ping 192.168.2.2. Destination host unreachable. The same thing should work over here. I just wanted to do that to show that we use wildcard masks, or we can use instead of masking it for a single IP address, we can use the word host. One of the ways that you can tell that your access list is working is we can do a show access list. And it tells us that here it is and how many times it's been activated. So the permit, we got 14 matches. We don't have anything for the deny because we use the implicit deny element for it. Everything that is in the default or the pre-configured or the whatever, the implicit here is not going to show up on the list. If we had done an explicit deny for that one, it would have been okay. We would have had that. Let's go to config T and interface gig 0 /0 and do no IP access group 1 to take it off. Access group 1 out because that's incomplete because I have to do the whole thing. And then let's do no access list 1 to get rid of it. The next thing I want to do quickly, and I'll do we just did the numbered list, now we'll do the named list to see some of the differences, and we'll do the extended. We'll do IP access list, and then what we can do here, we'll say it's going to be extended, and then I have to name it. I'll just call it my list. When I do that, instead of coming up and saying, okay, what's the next in the config, I'm in the config extended network access control list. And we'll do something really simple here. Let's permit 1.2 to get to the 1.2 to get to the HTTP and the 1.3 to the HTTPS. I've got them written down here so that we can do that. So on this one, we're going to permit host, actually permit, and then I'll do the question mark here. We need to specify protocol here. Since we're going to be using port numbers, we need to use TCP as the protocol. And then after that, I'm going to do host, permit host 192.168.1.2, and then the destination address. And it's going to be host 192.168.2.2, I think was the 2.2 is the address of that server. And then after that, we can specify what we want. We have equal, greater than, less than, not equal to, or the range of port numbers. And let's say, and this one's going to be equal to, and it was HTTP, equal to 80. And then we will permit host, and actually let's go through the whole thing. Yeah, permit TCP host 192.168.1.3 to get to host 192.168.2.2 equal to 443, the HTTPS. And at the marker to host, what did I mess up there? Oh, because I got too many dots here. When you make a mistake, the caret will point to the starting point of the error that you have. So now I have that, and if I show access lists, you notice that it interpreted 80 as 443. I had this on a cert test one time, and I kept going back and putting 80, and it kept telling me www. Finally, I just said, okay, that must be right. And it was right. So now then, we need to apply this list. And this one, since it is specific, we'll apply it on the inbound interface here, gig 01. Apply closest to the extended, or closest to the source. So gig 01, and we'll apply it inbound when we do that. So we're going to do to config T interface gig 01, I think, IP access group, and then we can have the word here, which was my list. Then it's going to be inbound as it goes into the interface. Now then, with any luck, 1.2 is supposed to be able to get to the HTTP. So let's see if he can get to HTTP 192.168.2.2, and we can. Let's see if he can get to HTTPS, because we have that implicit deny down there. And this one is one that sometimes I need to go away and come back. Okay, so the cache page was there. Now he goes through the process and the request timed out. Also, and this is just a little curiosity, you think we can ping it? Ping 192.168.2.2. Host unreachable, because we have only permitted the IP address to that single protocol, HTTP. My other device here shouldn't be able to ping 2.2, host unreachable. I should be, in this one, be able to get to the HTTPS. 192.168.2.2. And sure enough, I can, and I shouldn't be able to get to HTTP. I won't go back and make you suffer through that one. So how explicit and specific can we be in these things? And then if I go down here and show access lists, how many matches I have on each of the statements, and all these were permits. I could do a deny, and since I have these and we have that implicit deny, none of these guys should be able to get there. I know we haven't tried them out, but they should have a route on there. So we'll ping 192.168.2.2. Well, let's see. Oh, yeah, they can still get there because we applied our extended access list inbound. So now they can still, they're unaffected by what goes on here. And that is one of the advantages of this thing. The other advantage was we didn't have to type access list every time. The third advantage is they're numbered. So if I decided back to the one that I had before, I had the 1, 2, 3, 4, 10, 20, 30, 40, 50 on down the line, that's the default numbering system. If I decided I need to have something inserted in here between 10 and 20, when I went in and did the configuration of it, I could say 15 and then the permit or the deny or whatever I wanted to do. I could put the number in there and it will insert it in the proper order. We don't have to worry about, like we did in the standard list, that it is inserted at the bottom of the list. It becomes a little bit more difficult to edit those.